Tell you what, folks, what do you say we do a little something different this time? Wind up with a little shorter video, and let's see if we can't apply some of what we've been learning about how to follow lines on a schematic. Let's see if we can't apply some of that to a problem I'm experiencing with a radio I just bought from a Junk Collector. Now, if you've been following this series from the beginning, you should be getting a pretty good feel about how to follow lines on a schematic. Now, I didn't say read the schematic. There's a difference between reading a schematic and following a schematic. A person who reads a schematic is someone who not only knows how to follow it, but he knows why that capacitor is there. They know why that resistor is there. Okay, most of us don't know that sort of thing. We just basically follow the lines in the schematic and make sure that the lines go where they're supposed to and that the components are connected properly. The radio that I'm referring to is the Drake 2B, which I have here upside down. And if you watched my mishmash video, I think it was the last one, maybe number 151, I think was the number. Anyway, I showed you that this thing was playing a little bit. We could barely hear it out of the speaker, and there was some sound coming out of it. Well, I shut the radio off, and I went ahead and changed all the old wax capacitors out of there, got rid of them, turned the radio back on, and guess what happened? Not a lick of sound anywhere. No, it would not make any sound. I took the old, my probe from my multimeter, scratched around and stuff like that. Couldn't even get any static out. Nothing. So I said, well, that's just wonderful. So I had taken voltage readings, in the chassis before I changed all those capacitors, and before I even turned it on to get some sound that I showed you. And right here, you'll see that all of the voltages I have circled were good. All of these voltages were all good. Every one of them. So, now that the thing was not working, the old question comes up, well, what's going on now? The voltages are good. The tubes were each tested in my tube tester. They all tested good. Nothing looked burned. Everything looked pretty good. So I decided to go, this is all in the paperwork, by the way, in the manual for the Drake 2B. So I decided, well, maybe what I need to do is take a bunch of resistance readings, each of these pins off these tubes as listed in the chart to ground. Well, in the process of doing it, look what I've happened right here. Right here. Where are you at? I'm supposed to have 24,000 ohms to ground on the 6AQ5, which is V9. And what I have is 0. Now, I have a lot of other ones that are very low. Some of them are, like now 62.9 is probably acceptable. But 28.1 is supposed to be 42, and 13 or 12 is supposed to be 24. We may have to look at those later. But at least I was getting some kind of resistance reading. Okay, I highlighted them in orange. Orange is my favorite color, as you know. Actually, it's not, but that's the pen I had handy in my pocket. Right here's my main problem. I had 0 at pin 5. Pin 5 to ground gave me 0 ohms, and I should have had 24,000. What the heck is going on here? Let's find out what this 6AQ5 V9 is, and then take a look at it in the schematic of the radio of the Drake. Now, you want to see a schematic, check this one out, okay? Let me see, maybe get it right. This is a 2-page schematic. Get it both out here. And it looks really complicated. I know it does. Look at all those things. But I told you once before, it does not matter. It does not matter if it's this simple schematic here that we've been working on. That looks more and more simple every day, right? Yes, it does. Or one that looks more complicated. It's not more complicated. It's just that it's just a whole lot of crap sandwiched into a small area on 2 sheets. If I were to take this piece by piece and expand it and make it really large, like I did this one, take it down to Office Depot and make it what, 400 or 500 times bigger. I don't know what size it is, but if I could do that with this, it would look just as simple. So I'll tell you what, let's find out. I looked around and I found the 6AQ5, and it is right there. If I can get a little focus. There we go. I found the 6AQ5 right there. And here's pin 5 that I got 0 resistance at. But prior, when the radio was operational, when you heard it play, I had about 150 volts there. So, you know, this was really screwy. You know, I have 150 volts there, but 0 resistance. Let's take a look at this on the computer so it's a little easier to look at. What I'm trying to get at here is I'm not trying to show you how to troubleshoot. That's not the purpose of this series. The purpose of this series is to show you how to follow lines on a schematic so you don't get confused whether it's a big busy schematic like the one I just showed you, or the one we're now going to look at on the computer, or a simple one. It doesn't matter. Here's what we have. This is our 6AQ5. It is the audio output transformer. This is the primary. Remember, follow the line. This is pin 5 through the primary of the audio output transformer. Now take a look at this tube and use a little bit of logic. We have no sound coming out of our speaker. We have 0 resistance right here. Now I'm not saying we have an open. We have a 0, which means that something is grounded. And if we look out pin 5, we see that it goes to a capacitor right there. Yes, it does. That capacitor, if I get this in the camera here, where's my pencil? Okay, this is the plate of the 6AQ5. Comes off, goes to a capacitor. There's a capacitor hooked right there, as well as the primary of the audio output transformer, which is T8. If that thing were shorted, everything coming off that plate would never wind up in the primary of the transformer. And if it's not in the primary, it cannot go over to the secondary, okay? And if it's not in the secondary, it cannot go out the speaker, or in this case the headphones. That's the headphone jack right there. So could this capacitor be shorted? Well, I don't know. I went ahead and I tested between pin 5 and ground, which would, see if that capacitor is shorted along that line, and the answer was no, it was not. Well, wait a minute, that doesn't make sense. When I first tested it, it showed 0. Now I'm testing it again. It should have showed 0 again, but it didn't show anything. It just showed, I don't know what the resistance was, something like 19 or 20 K. What the heck is going on here? What do you mean 19 or 20 K? 1 minute is showing 0, the next minute is showing 19 or 20 K. I decided to go ahead and hook everything back up and turn the radio on. By the way, this plate goes to that connector right there on the pin, on the socket, through a capacitor to ground, through the primary of the audio output transformer to something called B1. What is B1? Let me see if I can find it. Now the audio output transformer and the 6AQ5 is on the right hand page of this schematic, this one right here. B1 is over here on the left hand page. So let's look at that on the computer. Right there is B1. This is the 6X4 rectifier in this radio. And it has 4 electrolytic capacitors. 1, 2, 3, 4. Now I know they're not drawn the way you're used to seeing them, but this would be the negative side right here, okay? This long line would be the negative side, because we know how to read schematics now. We know that there has to be a plate on each side of any capacitor. So we come down the plate, we come down the line, which is the plate for all, indicating the plate. And we go over here and we see that, yes, the negative side of the electrolytic is connected to ground. The positive sides are connected to this voltage dividing network, okay? Now, there's B1. And where does it go? Don't worry about these resistors. We're wanting to find out where it goes. It goes into pin 7 of the 6X4. So if I take my multimeter and put it on pin 7 of the 6X4 and pin 5 on the 6AQ5, I should get continuity. I have the negative side of my multimeter connected to pin 5, on the 6AQ5. Now let's go down here to the 6X4 and touch it to, let's get our multimeter here to see if we're going to get any continuity. It would be nice. Let's see if we can get some continuity on pin 7 of that rectifier. Here we go. Touch. And we do. Okay, what that tells us is what? What does that tell us? All right, let's go back and find out. See how much you've been paying attention to all this good stuff here. All right. All right, let's take a look at it. What that tells us is that we have a good connection from this point right here. It does not go to ground. I don't get a 0 reading. That means that cap is not shorted. And it goes through the coil all the way back to the rectifier, and I'm getting a 0.3 ohms. That means all of that is good, right? Well, if that's the case, I should get some sound if everything else is working right. And I should get some sound out of this radio. Tell you what, let's go ahead and take another voltage reading right here at pin 5 and see what I can get. Alright, let's take our voltage reading on pin 5 of the 6AQ5. I've got my multimeter negative connected to ground. I'm reading it from ground to the pin through the meter, or what they call plate to ground is actually the term to use. Let me go ahead and touch my multimeter. Let me get a light over here so you can see what I'm doing. I'm going to touch the multimeter right here on pin 5 of the 6AQ5, and I'm supposed to get about 150 volts. Let's see what I get. 151.7. I'll take that. Alright, let's get close to the speaker. As I was telling you earlier, there was no sound coming from it whatsoever. I could not make a sound. I couldn't buy a sound for it, okay? Let's see what's happening here now. Let's get real close, real down to it. There is a hum coming out of it. Hear it? Well, that was not there yesterday. It was not there this morning. All of a sudden, it's working. What you just saw, ladies and gentlemen, and I'm glad this happened. What you just saw is what we call magic. It's magic. It fixed itself. Now, of course, you know, we were able, because of our sleuthing ability with schematic lines, we were able to pinpoint it down to a section. So what I'm going to do, by poking around down here with my probes and everything, there may be a bad solder joint. I'm going to go ahead and take my soldering iron, touch a bunch of joints down there, and make sure they're righteous. And hopefully it'll stay the way it's supposed to stay. I'm going to hook it up to an antenna later when I get home tonight and see if I can get some better sound out of it. Remember, you saw it here, magic. When they fix themselves, it is magic. Until next time, this is John.